Okay, good morning, everyone. For today's session, we have with us Dr. A M Pande, sir. He will be delivering his session on prerequisite of design structure, important codal provision. Uh, so you can start with your session then.
Yeah. Good morning, all of you. Okay. I'll be starting on this presentation. It was originally this year specially made on request of many consultants because many of the codes we are not aware about. When it comes to 800, 456, 1343, 1893, I think everybody knows these codes. So I prepared specially this presentation for the benefit of consultants earlier and then slightly modified this for the benefit of all of you. So when we look at the structural design, we have to understand codal provisions. So in my scheme, there is brief about Indian standards, a small quiz. You need not answer the questions, but that will charge you to look into details of all codes. Then relevance of latest versions of codes, and of course the amendments. Then some of the codes related to structural engineering. Understanding the codes. This is very important because it's not reading the codes, it is understanding the codes. There are many codes related to civil engineering materials, and many of us they are not aware about the things. And then I have put one assignment. Before going forward, I think everybody knows that you can download any code from the BIS site. If it is not, if you are not aware about that, I'll be explaining that thing also. Just you have to log on to BIS, put your credentials. You can download any code for your own benefit. You will be getting it in PDF form. So don't worry, any code can be downloaded, any code amendment can be downloaded. So let me begin with this. The Bureau of Indian Standards is the national standards body. It is under the Consumer Affairs, Department of Consumer Affairs. The organization was formerly known as ISI, Indian Standard Organization, and then now it is Bureau of Indian Standards. I don't know how many of you they are aware about National Building Code. Earlier case, I remember when I use this code, I had to purchase National Building Code. It is in big volume, maybe 3000 plus pages. But now you can very well download it, and if you have very good your net connectivity is excellent, it will not take much time. You can get this. So National Building Code, we are expected to review for many things. So volume one is just a forward committee composition, etc., etc. There is important explanatory note for the users of the code. So if you refer to this, then you will understand which way you have to proceed and get the information, whatever is desired information. Then part 1 has definitions, then administration. Part 3 is development control rules and general building requirements. Probably you will have to refer to part 3. Part 4, fire and life safety. Part 5 is building materials. Part 6 is structural design. So whatever is structural design details given in this National Building Code, many things for beginners they have already come in this National Building Code. But then you will be required to uh, actually visit or read or understand the relevant IS codes. Soils and foundation, timbers and bamboo, masonry, Now, if I ask you, what is the code related to masonry structures? So many, you see, we know IS 456, we know many codes related to concrete, but masonry structures we are not following because maybe I don't know why, but even in syllabus, there is no wide kind of coverage on the masonry structures. Of course, I will be dealing with that plain and reinforced concrete, pre-stressed concrete, steel. So I'm just going through details. The next volume is volume 2, explanatory note for users of the code. This is what we are supposed to go into details. Then only we can understand the codes very well. Construction management practices and safety building services. Services, probably you will have to refer to this: lighting, ventilation. So in one of the presentation, I made a presentation on sun path analysis. Probably it is not covered in any other code, though it is more related to architecture. But every engineer must understand what is sun path analysis, what is a green building. All this they have been covered in the National Building Code. Plumbing services, etc. The details are available in National Building Code. Landscape development, that is also available. Part 11 is approach to sustainability. So, approach to sustainability, this is what we are focusing more. And those who are interested, I'll request them to go into details of this part 11. Now, this is just small quiz. Write code numbers and names of structure engineering codes other than 800 and 456. And write code numbers, names of civil engineering materials related codes. Now, when I ask you this question, I think everybody must have started thinking 456, 800 that you know, 1343 you know. You may be knowing 455, 457. You may be knowing 3370, 1343. Maybe we are studying pre-stressed concrete, so that many of you know. And code numbers of civil engineering materials related. So when I ask you this, I think many of you, those who can write at least 5 codes, that is a great thing. But after my presentation, at least I know you will be knowing around 20 different codes. Has anybody even uh, thought of any code related to excavations, soil explorations, say 1892 and then 3764? These are the codes. Probably many of the consultants even they are not referred. So I'll be focusing on those codes also. Now, every college we have codes, but unless you download latest versions of codes and amendments, you will be put to many difficulties. So you should always watch for relevant versions of Indian standards, watch for all amendments. So avoiding latest amendments may lead to undesirable calculations. So I have put some examples over here because I wish to emphasize on the use of latest amendments and whatever are latest versions. Now 516 is the code which we normally refer for concrete strengths. But recently it has come out with fantastic kind of, it's a complete code with 12 parts. And those who are using earlier version, again there are many changes. Determination of strength of hardened concrete, that of course many of you might have followed. Properties of hardened concrete, it's okay. Making curing determination, this is also okay. This is related to accelerated cure. Part 4, sampling, preparing, testing of concrete cores. Part 5 is non-destructive testing of hardened concrete. Now, NDT, I think in most of the colleges, NDT is being taught or so you have been referring 13311 code, and now it is no more there. It has come out with a part of IS 516. Creep of concrete, models of elasticity in compression, wear resistance, bond in reinforced concrete, determination of Portland hydraulic cement concrete, water soluble. See, these are many things they have been covered in IS 516, and you should know this. See, I remember one of the project in which it was of different guide, and the student is casted fantastic. Sir, well, we I am testing for bond. Just visit the lab and guide me. I said I will certainly visit. But when I looked at his samples, there were around 56 different samples. It was my comment that you are not followed IS 516. He was not knowing IS 516. So even whenever you are testing concrete samples in labs, maybe many of you who are teachers are offering projects on concrete. So my advice to them is this is the most important code, IS 516. You must have this code and you must understand various provisions of IS 516. So IS 516 for me is the most important one for testing of hardened concrete. So original codes 13311, they are replaced by IS 516. That is part 5, section 1 to 4. So non-destructive testing provisions, they have been incorporated, but they have been modified. So those who are following 13311 part 1 and 2, there are great changes. Details on the frequencies of transducers have been updated. So again, if you are following this course, you will be put to trouble. Then more details they are included on surface preparation. Earlier code, the surface preparation was not very specifically, though it was mentioned, but now they have brought in uh, a better kind of option for surface preparation. Velocity criteria, they have also revised, and more details have been given on effect of various factors on pulse velocity measurements. See, those who have followed the earlier code, many times it so happened that your rebound hammer used to give good results, but your pulse velocity was not giving proper results. So if you follow IS 516 part 5, then you will understand this in better way. So if you look at the text, the blue text, it is all hyperlinked, but unfortunately the hyperlinks, they are not working over here. So I'll, once my presentation is over, I'll be showing you some details of this course. There are classic examples of amendments. Now IS 456 that most of you are following, just look at C, soffit formwork to beams, minimum period before striking formwork, it was mentioned 7 days. Now if you use, the amendment has come, if you use OPC, then you can strike it in 7 days. And for concrete made using cement other than OPC or using mineral admixture like fly ash and slag, now you can strike the formwork in 10 days. So there are some modification, props to slabs, that 4.5 meter. Again, for this kind of cements, it has come to 10 days. Why I am emphasizing on this codes? Because you will be you will be, some of you will be doing construction work. And if you are having older version of code, you will try to strike the form in 7 days. There are many cases in which the slabs they are sagged like anything. So you have to be very careful about not only this code, but that 4326 you will have to understand. RMC code probably everybody must understand properly. Now 875 part 3 on page 11, there is substitute solidarity ratio phi for solidarity ratio. See, many times in this course, they have made some mistake. There are typographical errors. And if you try to follow these errors, then your calculation will be totally different. Now, pressure coefficient Cp, the earlier code that end surfaces, if you look at this particular table, for C dash, it was minus zero point 0.8. That was typographical mistake. And they have come out with C dash now plus zero point 0.8. See how much difference this can make. Means probably you are thinking that there will be suction. Now it is not suction. It is the pressure on the shades. So that's why, see, I'm focusing on these amendments only to make you aware that if you are following a particular code, older versions, your calculations may prove to be wrong. This is the very classical example. IS 875 part 3, dynamic wind effects. If you are referred or if you are used any time, the formula was in the earlier code. Even earlier code means that is even 2016 it has come. You look at that under root, it is 1 plus g square. And of course, I was a project guide. There was a difficulty to my student. Sir, 1 plus g square, मैंने 1 point, I have taken 9.8 at g because g is 9.8 meters per second square. I said, there must be some mistake. Why I realized? Because they have explained all symbols there itself. But this g was not explained. So I went for the purchase of this code. That time, I think this was not available online free of cost. And then in the amendment, I saw it is 1 plus phi square and not 1 plus g square. Page 47, clause 10.2, line 28. And phi is a totally different factor to account for second order turbulence intensity. It has to be calculated differently. And if you are using 9.8 meters per second square instead of this factor, your calculations are going to be absolutely wrong. So, whenever you are reading the code, whenever you are using the formula, you see to it that all symbols are explained properly. If they are not explained in the code, then at least you search for amendments or any revision kind of thing, because whenever this kind of ambiguity comes, it is immediately referred and the BIS they come out with the appropriate correction. If you find anything wrong, you can also write directly to BIS. 875 basic wind speeds. Now look at Almora. In earlier code, it was 47 meters per second, and now it has come to 39. So, in Almora town, or even in um Almora and Amritsar, you will find there is a difference. In Almora, the basic wind speed now we are taking on lower side, and Amritsar we are taking on higher side. So if you try to follow the earlier codes, probably you will be over designing structures at Almora, and you will be under designing structures at Amritsar, because now the speed at Amritsar is 50 meters per second. My focus on so many slides right now is on the amendments, that everybody must go into details of amendments or latest versions of the codes. And those who have not worked on this, if you just try, you will find major differences, and you will realize that you have made some calculation mistakes at some point of time. Now this is 1343. Again, it has come in different way, amendment. So that is also of very much use. Now 1893 I have extensively used, and in earlier cases, if you look at the first part, the amendment has come, substitute R1 delta 1 plus R2 delta 2 divided by 2 for R1 delta 1 plus R2 delta 2. So whenever you are putting a factor that divided by 2 in any calculation, it makes lot of difference. Then here in the text you will see R1 delta 1 plus R2 delta 2. But now you have to take this as R1 delta 1 plus R2 delta 2 divided by 2. There is another mistake. If you look at this original, the bracket, where is the square? Zero point 0.2 plus LWI upon H, that square. And now with amendment, it has come out as AWI into zero point 0.2 plus LWI by H, whole bracket square. So that zero point 0.2 square carries lot of meaning. And AW, which might have calculated using earlier code, there is great mistake. So focusing on all this, you have to remember that you have to follow amendments for every code, and you can get amendments easily, absolutely no issues. Now, important structure engine codes, there is a need to understand all relevant provisions of codes. Now, how you can understand this codes provisions? I'll uh, explain you. So you can develop a word file or containing relevant provisions or a PPT. If you regularly read these files, you will understand the codes in better way. Okay. Now, if I ask you, everybody knows IS 456. I don't have any doubt that you know IS 456. But while discussing with students and my colleagues many times, I realized that probably many of them, they were not aware about what are the contents of IS 456. Contents related to structural design, yes, everybody knows. But contents other than structural design, they are not known to many of these people. This was my observation. Probably your observation may be different. See, IS 456, why I'm showing this is a simple thing. I want everybody, once you go for the latest version of the code or amendments, you should look at the index first. So, materials, workmanship, inspection, and testing material, cement, mineral admixture, aggregates, water, everything is available in 456. Maybe, probably you will have to refer specific codes whenever it comes while directly using properties of concrete, workability of concrete, that is given in 456. Durability of concrete, requirements for durability, that is also given. Mixed proportioning, of course, you will get information, basic information in 456 itself. Production of concrete, quality assurance measures, batching, mixing, form work. Now, form work, that is also included in IS 456. These are general requirements. I'll be covering specific code related to form work, but even these are mentioned. Assembly of reinforcement, transportation, placing, compaction, and curing, etc., etc. This is also given in IS 456. Construction joints, cold joints, curing, supervision, concrete under special conditions, underwater concreting. So many times it so happens that when you are required, the 456 is handy. But once you look at 456, probably you can get into touch with, because this code also mentions other relevant codes. So you can get other codes also where underwater concreting, how it can be done. Sampling strength of designed concrete mix, even that is mentioned over here. Inspection and testing of structure, of course, this needs revision because a new code has come, so that will be incorporated. But there is a mention about the standard in 456. You have to refer for the latest version of that code. This is probably everybody knows, that is general design considerations. This most of the students and faculty, they follow this part. Stability of structures, that is also here. Fire resistance is there. Loads and forces, they are also given. A brief introduction is always there. Solid slabs, compression members, and that most of you might have referred. Special design requirements for structural members and system. Now, concrete corbels, deep beams, ribbed hollow block or voided slab, these are also given in 456. What you are supposed to do is you just refer this, and whichever code is mentioned over there, you try to follow that code. That will help you in understanding these things. Flat slab, of course, those who are design flat slab, it covers in this. Walls is also there. Look at section 5, limit state method, that most of you or who are teaching structural design or who have learned, they have followed this. So I'll not be speaking much on this, but I am just showing you this is the importance of index of any code. So if you read the index carefully, you will get lot of information. So I'm just showing you calculation of deflection. Everything is given in 456. Now, forward reading is also very important. See, any new version of code has come, you will have to refer to the forward. Unfortunately, what has happened is yesterday I uploaded my presentation, then in the evening I modified it for bringing some text. But since that was uploaded, it is opening that. But remember, I want everyone sitting over here. I'm not asking you to read all forwards because you will get a lot of information forward. There is a code 3466. You can note down IS3466. You can download that code and just look at forward zero point 0.2 section. It is part of zero point 0.2 of IS3466. Of course, it will be there in my presentation also. So we'll be focusing on that. So unless you read the code carefully, now I'll give you 2 3 minutes. Like request to organizers, can someone speak on this when I'm raising the query? There are two photographs. What is common in these two photographs? Can you allow someone to speak?
Participant, if you want to ask something, you can.
Yes,
Uh,
yes. I am asking the question. Try to
okay,
find out common thing in two photographs.
so you
What
can comment whatever your comment is in in the chat box, and we will show it to the AM sir.
Okay. The what is common is water tank they have failed. This is Gujarat earthquake. And in the first photograph, it is the water tank which has failed. Second photograph is fantastic. One is fully constructed building and another is under construction. In both the cases, we can see failure of water tank. No, it is constructed in India, in Gujarat. So only one small thing they have not followed, and that has resulted in the failure of water tank. What is that? Now I want everyone to read the text. This text, if it is visible, all of you please read. So, what is most important in this? I'll read the text. Small size facilities like towers, tanks, parapets, smoke stacks, chimneys, and other vertical cantilever projections attached to building and projecting vertically above the roof, but not a part of structural system of the building, shall be designed and checked for stability for 5 times the design horizontal seismic coefficient AH as specified in 6.4.2. This is part of IS 1893. See, what happens is whichever sections we need, we try to understand those sections. But now, if you wish to become a good structural designer, see to it that you understand relevant clauses. Now, not this is not my research and other things. I've been attending many lectures, and this was by Dr. A. Sarya. A. Sarya is a Padma Shri, and he has done fantastic work on earthquakes and, of course, steel structures also. So you have to find out relevant clauses. Otherwise, what would have been done in the earlier photographs? If I go back to photographs, It is failure between the water tank and the column, the part. Had it been designed for age 5 times, it could have saved this water tank. The reason is very simple. It is lump mass at some height, and during earthquake, its behavior is different than whole structure. So we have to understand all relevant clauses carefully. So when I look at 1893, it must be read along with IS 4326 and 13920. What is this 4326? Many will be surprised to know that this 4326 has given some comments somewhere which are very relevant for from earthquake point of view. Then excavations, even while traveling with very recent times, traveling with structural designer, I could check that the excavation for tall structures. My comment was very simple. You are not followed IS 3764. So 13920 4326. Then look at another code 1904. General requirements for design and construction of foundation in soils. So I request the organizers at the end of my presentation, I like to show you 3764 and the last part, that is worksheets. See, when it comes to IS 875 part 3, that is dynamic wind effects, gust factor method. So if you go through those clauses, you will find it very difficult. There are big formulae and graphs and all these things you have to follow. So when we look at something very complicated, understanding it becomes difficult. So I have prepared some worksheets, which normally I used to give to my students when I was teaching wind and earthquake. So the I never believed that these worksheets could be beneficial, but when I started using these worksheets, almost every time, at least one student was interested in having project, his PG project on dynamic wind effects. So creating these worksheets, you can very well uh, understand provisions of this course. Can I try once if you can see? No, these are not available. The hyperlink is not available. I'll show you. Look at the buildings. The buildings are that way, they are intact, well constructed, but they have forgotten to take precaution as far as liquefaction is considered. Liquefaction, when it is non cohesive soil in the presence of water table and shaking, there is reduction in shear strength of the ground, and these buildings they tilt. See all the three photographs. In one cases it has gone below and the road has come up. In second case, the building has tilted like anything. From ground floor to top floor, it is intact. And third is very fantastic case where the building has tilted by 45 degrees. The building is intact. So structural design was perfect. But the precaution was not taken for soil liquefaction and building has tilted. So you have to find out some clauses which are given in 1904 and 4326, because these codes they have very clearly mentioned that for you have to carry out analysis for soil liquefaction. If that is not done and earthquake comes, your structure is liable to collapse. So 4326 and 1904 code, they must be referred appropriately. Now there are three more photographs. The buildings they have tilted, there are almost no major damage to them, but the buildings have become unusable. We cannot use these buildings because they have not followed important clauses of 1893. See, what happens is at stilt level, the stiffness is on lower side, upper floors, the stiffness is on higher side, and there are shaking horizontal movements. So, because of that, the stiffness variation results in a major problem that the floor having lower stiffness gets collapsed. And that is, so buildings are standing, but buildings are cannot be used only because their ground floor has gone. So we have to remember, whenever you are studying 1893, try to see all relevant sections. Now you can very well have soft copy, you can highlight some of the important text so that whenever you are referring the code, it will be easier for you to see the provisions. Now at the end of my presentation, I will be showing you these things 3764 and this 1904. This course I like to show you because this course, whenever I am interacting with many people, they have not referred much this course. So just note down IS 3764 and IS 1904, and those who wish to learn something different, you just try to follow important provisions of this code. 516 I have earlier said, this 3764 and 1904. Try to refer. Other important codes 1343, many of you know, 3370. Water tank staging 11682. Steel reinforcement 1786. False work for concrete structure 14687. Now, if you refer this code and if you read it carefully, if you try to understand the code, you will find there are some fallacies in this code 14687. So, those who are interested in understanding the codes, I request them to refer or even read 14687. 10260, many of you know. 2950, rough foundations. So I just given a sample list because my contention is not that to make you aware about every code. Basically, I'm focusing my lecture on the theme that you should know there are many codes, and if you try to understand these codes, that will help you in becoming good structural designer. Those who are in teaching, you can offer very good projects on this course. Now I have kept this slide purposefully blank. Normally we overlook the materials. Now whenever I start with this course, I normally ask the participants, but this being online, I cannot see you people. But if I ask you simple questions, What are the mortar combinations used in practice? Everybody will say, sir, 1 has to 3 sand cement, 1 has to 4, 1 has to 5, 1 has to 6, 1 has to 7. Now, is there any other kind of combination? So that's why I always try to focus on this, that these codes, they are normally overlooked. Let us see. Now, earlier I mentioned that all must understand IS 3466, and especially in the forward, that section 0.2. What is written over there? It is ordinary cement mortars, although fast setting and capable of high strength development, are harsh, non plastic, non cohesive, with the result that they cannot take up shrinkage and temperature movements in the masonry, and are liable to result in comparatively wide cracks passing right through the bricks or building blocks as compared to a number of evenly distributed hair cracks in the joints which occur when weaker mortars containing lime are used. This is what the code says. And when the code says, that means it has theoretical as well as experimental or the empirical background. Now, just try to refer back to the constructions when we were using normally 53 and 43 grade cement. PPC has come a bit later. So those who have seen the structures, they must have seen some white patches, concrete as well as masonry. You have seen white patches. Why that was happening? A simple reason is hydration of C3S results into calcium hydroxide formation, and that there are shrinkage cracks, so it comes out. Now, when we are using weaker mortars or even we are using PPC cement, the fly ash has a capacity. There are two things: secondary CSH formation and pore refinement capabilities. So, because of that, this has taken some care. Now if you try to understand, nowadays they are using crystalline admixtures. So when that admixture interacts with there is a reaction between water and that crystalline admixture, it forms crystals, and there is pore refinement. So the technology is advancing and we must understand the technology. So this is 3466. It is a code on masonry cement. We are not using masonry cement, but there is a code. Now try to understand the practices in US or European countries. They are not using high early strength cement for masonry structures. There, the cements they are used, or in European countries, it is always ready to use mortar mixes. Americans, they are not, means it is clearly mentioned in their code that highly strength cement at type 1, type 2, they should not be used for masonry structures unless specifically required. But what we have been doing in India is we have not made the constructors aware about provisions of the codes, and we have not come out with kind of required mortar combinations. So that's why we are still using cement sand mortars. Let us see the combinations. This is 2250. IS 2250, and if you look at table, cement, lime pozzolana mixture, sand, they have given various combinations and compressive strength at 28 days. So it starts with mm zero point 0.5, mm zero point 0.7, mm 1.5, mm 2, like that. Now the basic question is, in our rural areas, if you are getting bricks of 35 Newton per mm square is 35 kg per centimeter square that we normally use. Now, what kind of mortar we should use? We should not use same kind of mortar for the same type of masonry unit. So the strength of masonry unit, if it is on higher side, we should go for strong mortars. If it is on lower side, we have to go for leaner mixes. And right now in first page, you can see 18 different combinations. But if you look at these columns, cement, then lime, pozzolana mixture. Sand is common, cement is common, or many times lime replaces cement. But there is lime pozzolana mixture. And this code is 4098, IS 4098. It has given different grades of LP mixes, LP7, LP20, LP40. And the code has given that if you are interested in achieving this much time, try to use this combination. Code is giving for last many years, but if you try to search in market, we don't have LP mixes. And what cement we are using for masonry is PPC. Nowadays PPC, it is having strength 53 Newton per mm square or more. Now just look at it. How much? I'll go to next slide and then we'll discuss this. Now, what is the highest grade of your masonry mortar? It is mm 7.5. The code is saying, and compressive strength is 7.5 Newton per mm square. Now, just look at this. We are not required to use mortar having strength more than 7.5 Newton per mm square. Why? Because if you use this high cement kind of mortar mixes, they are liable for cracks, shrinkage cracks, and that renders masonry a well bit on lower side. The strength is on lower side. There are leakage problems. There is efflorescence and many things. But if somebody recommends that I will be using the best quality of mortar, that one has two, three standard cement sand mixture, the 53 Newton per mm square is the strength of that. You are required for best quality of bricks. And this is required somewhere in Gangetic belt where you have the best quality bricks is 7.5 Newton per mm square. In Nagpur, we may require just 3 to 5 or 5 to 7.5. And if you use this high grade mixes, that means you are compromising on the quality of masonry. Now, this is not the only code 2250, there is another code, and that code is 1905. 1905 reinforced concrete masonry. There is a code, but this code has also given some guidelines for use of mortars. And if you try to compare IS 2250 and 1905, you'll be surprised to know that there are this comes 36 and that is around 26. But there are only few common mortar mixes, and this comes out to be around 51 different mixes. And majority of this combination, they suggest fly ash to be part of masonry mortar. So, important codes related to civil engineering materials 269, that is for cements, 1489, this is for PPC, 1905 for reinforced masonry, 2250, I have just explained. 4926 is the code that everybody must understand. Now, when I am saying 4926, you have to use, it is related to ready mix concrete. Everybody will, those who have not gone through this course, they will think that it must be giving what kind of strength and other things, but it is not giving that kind of thing. The certification, then the responsibilities of owners, contractors, and suppliers, all these things they are detailed in this code. So I have earlier said 37, that 37, then I think 1892 probably I was saying 1904 and 4926, 4326 I have said, 4926 I want you to refer. 457 for mass concrete and 455 for Portland sack cement. These are other important codes. I have deliberated more on 516 because I was emphasizing that time on the relevance of the latest versions and amendments of the codes. For codes for bricks and blocks, 1077, common bird clay bricks. 3495 part 1 to 5. Now, this is one which those who are uh, interested in working on masonry and those who are not offered so far projects on masonry units, they should focus on this. 3495 has given simple tests on burnt clay bricks. You must have the dimensions and other things, everything. So I want you to go into details of 3495. 12894 is pulverized fuel ash lime bricks, that Falji bricks. We are getting Paul bricks in Nagpur. They are manufacturing as per 12894. Concrete masonry units, they are in four parts, 2185. Chemical resistant mortar is 4832. Precast concrete stone masonry blocks 12440. Grouting materials for alloy grouting 14343. 15658 paving blocks, and 3812 is pulverized fuel ash. It is come in two parts, 1 and 2. So fly ash, those who are using must understand 3812, as well as there is another code for testing, that is 1727. How you can get any code? You have to simply register on BIS website, log in. You can download any code, including special publications. This, those who have not used this course, and you are expected to use it for personal purposes, not for commercial uses. So you can get this course. Anybody can get the code, and you can download any code, try to create your bank, and just look for the amendments. They look for uh, whatever you want. You just try to search in one code what are the relevant other codes. Try to get those codes. If you can work on this course and if you master this course, see, you will be good advisor to many. So my request to all of you is to choose any three structural engineering related IS codes, compile information of minimum 10 important clauses, then civil engineering materials related codes, and compile information. If you try to follow this, you will understand the system, the importance of this. Here, though I am concluding, but I will be showing you some of the codes. Try to understand relevant codes. You can download any code for personal use. Look for amendments and don't miss any important section. Here I am thanking you, but I am not closing it. I'll show you some of the codes because since hyperlinks are not working, I'll I just request organizers. I wish to show you some codes.
So you have to minimize your screen and go to the code.
This
Yes,
is
we can see it now.
You can see this calculation of dynamic wind force.
Yes, sir.
Okay,
Uh, 1 minute, sir. But it is not that clear, sir. I think you should have to zoom it a little bit.
okay.
Yes, sir. Now it is visible.
Now, this is what I was telling you. To understand critical provisions of code and calculations of dynamic wind force on structures, it is a complicated kind of thing. So, what is the first step is try to understand what are the important codal provisions, and you can jot down this. So, in sequence, so buildings and closed structure with height to minimum lateral dimension ratio more than 0.5, 5.0, etc., etc. Means try to understand. The second line is building and closed structure whose natural frequency in the first mode is less than 1 hertz. This indicates that any building more than 17 story will be required to check dynamic wind effects. So it is better you write down all formulae first. All codal provisions you can take the provisions from the code, put it here so that in logical sequence you are putting all code. I'm not going into details of the things, I'm just explaining the system in which we work. Now, when it comes Gauss factor, the formula I have written, whatever the formulae, page number in that code, everything you try to mention. If you mention these things, then you will be easily grasping these codes. This is given in the code, and the amendment, whatever is given, I am highlighting. So all important formulae and from various pages, I am just putting. Just look at. You are not supposed to understand everything right now. It is the system you can very well follow. All formulae related to that, I am putting at one point. I'll be using this formulae for further calculations. See, it looks to be very complicated. There are many formulae. The formulae are very complicated. You have to understand everything. You have to calculate the things. You have to take it from graph and many things. So this is that. Now a typical problem you have to take, and you have to you have to take height of building something, so maybe more than 50. If you wish to work on this, you get the things, then start calculating everything. Whatever I have mentioned earlier, codal provisions in logical sequence I have written, and based on that logical sequence, we can work out in the sheet. This is first. Then whatever is next, then this is the formula. But for this formula, we have to calculate many things. So whatever is required to be calculate this IZ, calculate R, whatever is the. So any problem you take, even in design problem you take, analysis problem, whatever you want, but you write down the codal provisions systematically and prepare a worksheet. This is a worksheet. So once you calculate everything, see why what I was telling is logical sequence of the formulae. In some cases, the formulae are given first, and then you have to calculate many factors based on that, and then incorporate in this. So what I have done is written the formulae, but later on I have calculated it. So what is required in the formulae, this is what, this way, see, it is complicated. Finally you can calculate this. If you can calculate this, then you can very well even use Excel for calculating this for various conditions. So this is one thing which I wanted to show you, that any complicated thing in the code, you try to prepare a worksheet where you are writing the formula and calculating the things. If you follow this system, you will understand codal provisions. So my aim to show this was just to how you can master the codal provisions. This is that. I will now show you some more codes. 4326. Can you see the code now? 4326. Hello. Can you see
Yes,
the code?
yes, sir, yes, sir.
This is very important. Earthquake resistant design and construction of building, this code practice. This everybody should read. What are the changes and other things. Definitions are there, references. No, what I am saying is references. Here, reference is given 456 1978. So you should go for the latest version of the code along with amendments. So if you try to download all these relevant codes, see in this, the 1904 code has also come, 1905 code has also come. This is masonry. Code of practice for design and construction of foundation, it has come. Center of rigidity has come. Projecting and suspended parts, it is mentioned clearly. It has also mentioned about building configuration. See, for 30 plus stories onwards, we have to have the configuration. Means those who have heard that it is frame, then tube in tube, bundle tube, frame tube. There are many such configurations that you can very well follow. Foundations, I'll show you only one clause. Ductility, it has mentioned. See, some of the things of this code, they are not referred in 1893. Foundations. In this 5.3.3, loose and fine sand, soft sealed, expansive clay should be avoided. If unavoidable, the building shall rest either on a rigid raft or foundation, etc., etc., etc. So, about foundation, this is very clearly mentioned. And there is a term related to, so this is one code which I wanted to show. Then 4326, 4926, I wanted to show you. This is 4926. Can you see this code?
Yes,
Can you
sir.
see the code? Yeah. 4926 is very important. That थोड़ा उसको मैं expand करता हूँ. Ready mix concrete, general requirements, basis of supply. transport of concrete, time in transport, sampling and testing of ready-mix concrete, workability, compliance criteria. Now, this is very important. Information to be supplied by the purchaser, information to be supplied by the producer, production and delivery, even plant, office building, etc., etc., that they have covered, quality control, there's order processing, even that is. Training is part of this RMC code. And there are some more details. Even this is what is important. Concrete mix information to be supplied by the purchaser. There is a pro forma. So this is the code I want everybody to understand. Then 816516 was 3764. I think it is here. Yeah. This is what I wanted to show you. Excavation work, code of safety. Terminologies, they are very clearly mentioned. General recommendations, shoring and timbering, sheet piling, inspection and examination. Excavation, it is very clearly mentioned, but I will also show you some of the things. Loose side material, how it is to be dealt with. Means of access and escape. So when you are excavating for a building, there should be pathways, there should be gangways, there should be ladder, provisions of fences, guards, provision of lighting and warning signals, safety rope, लोन वर्कर, एक ही आदमी वहां है काम कर रहा, तो उसके लिए क्या होना चाहिए. All these things they are mentioned in this 3764 code. So this is another code which I wanted you to see. This is 1904. I like this code because general requirements for design and construction of foundations in soil, code of practice 1904. Site investigation. Now, when it comes to site investigation, there is code 1892. I'll show you this code also, how detailed they have carried out the things. So, the purpose of showing you all this is to make you aware about various codes. These surveys should not intersect. When it is on sloping, then what are the precautions to be taken? That is also mentioned. Seasonal weather changes, landslide prone areas. See, what happens is many of these they are not normally taught in the class. So we can skip those things. Hardened concrete test, non-destructive testing of concrete. The first thing what I want is, if you refer to this, read the foreword. What are the details they have been they have incorporated? Full details they are given. And in earlier code, even there was the statistical analysis, but that code is also withdrawn. So there was difficulty in getting how which readings we must keep. So many modifications you can see in this code. I'd like to show you 1892. Let me check. This is 11682. Criteria for design of RCC staging for overhead water tanks. This I want those who are working on water tanks. See, I have seen some projects in which they have very well designed the structure, that is water tank, but staging was not designed as per the provisions of this code. One more thing. Okay, I think I could show you many codes. 1892 somewhere. To conclude, what I feel is, okay, the uncommon codes, I want you to go through it, try to understand specifically, try to understand the amendments, and for any complicated kind of thing, you try to develop worksheets so that it will be easier for you to uh, understand the codes. So last 5 6 minutes, I like to give any input or any query you have. You can ask me. You can raise the query so that I can answer your queries. It is up to organizers to permit them. If I can see their comments or their queries, I can answer the queries.
So participants, if you want to ask any questions related to the search topic, you can write it in the chat box, and then we will show to sir, and he can answer your question.
So those who are offering projects based on civil engineering materials must understand codes and then only offer. And you try to include. See, when you compile literature, you also ask them to compile information related to relevant IS codes. So if you have that information, you can very well master all the codes. Even in designing, we directly follow the codes, but try to have the habit. Means if you tell your students while submitting assignment which section for this calculations you are doing, from which page of the code, that will also help you in understanding the codes. Do we have students also participating in this?
So mostly faculties and research scholars.
Yeah. Those who are working on this course, anybody working on Flash or for research? Because couple of days ago, when I was talking to someone who was working on Flash, I said, "Have you referred 1727?" Sir, ये क्या होता है? That should not happen with you. You should know the codes. So if there are no queries, we can close here. Are
Yes,
we
sir.
done with this one?
So we will be sharing the feedback link in the chat box.
Yeah.
And if you have any question related to search topic, you can ask
Then
over
I
there
can
also.
answer your queries anytime.
Okay, sure, sir. So thank you so much, sir, for your informative session and giving us your valuable time.
Thank you. Thank you
Thank you
very
so much.
much. Actually, I was running with high grade fever. Still,
Okay.
I could talk for more than an hour. That's it. ठीक है ना?
Okay.
So
Thank you so
shall
much,
I
sir. Yeah,
leave?
yes. Okay.